Hi, welcome to another video on my Raspberry Pi 2 running Ubuntu Linux with the robot operating system and a full high definition screen, which makes it a lot easier to show things. As you can see in the picture in the middle, the motor I did try last time with the propeller is running. This LED is burning, but what you can also see is that the ROS nodes, publisher and subscriber, are not running. Taking a look at the publisher, it is supposed to work. So why is the motor running while apparently the signal is on? The signal coming from here towards here. No transistor, just a simple signal, and it works apparently. I want you to see the LED. So, what's up for today? See if everything works. Start the publisher. Then of course start the subscriber. And then indeed it is noticeable that GPIO7, which is the feedback for the signal of the motor, is indeed positive. But that is impossible because the data is negative. And that is very logical because the switch is not pressed. Now I switch it, and in the upper terminal window you can see the output from the switch immediately going to 1 because I fixed the wire last time. And then you can see GPIO7 is 1. Well, that is logical, but still data is 0. So how is that possible? That should not be. And this is a mystery that I left you last time. Why is this signaling not alright? You can see that I've released the switch now. This is all 0. Here is all 0. But here it remains 0. So something is not quite right. And that certainly goes for the output. Is the GPIO wrong in some respect? I did try the GPIO test a while ago, and by doing that I found back then that there was nothing wrong. But if this is positive at all times, that's not good. So I guess I should better perform the test again, and then I have to disconnect this cable from the GPIO, because I want to be sure if the GPIO really is correct or not. Downside is that if I stop this, it makes no sense right now. The motor keeps working, so see, that is a point. Let me interrupt myself. Which is easy to do. You see that GPIO 7 is 0 right now. It is 0. While it is, that's interesting to see. So now it is 1. And I put it in the ground, and it's 0. So what happens if, oops, this wire should stay connected into the motor. So, oh come on. So what happens if I do press the switch? That's an interesting thing. So, with the wire now connected to the ground here, when we press the switch again, see what happens. Well, the switch says yes, but as you can see in the lower terminal, it stays 0. So that's not good. That's not good at all. Do I need a resistor in between? That is possible. I have a resistor at hand, though not the right value. Yeah, I do have. So I could put a resistor in between. Will that matter? Not quite sure. But this is quite remarkable. This makes plus, and this doesn't. So instead of making the switch the source of the one, it is the motor, which means that the wiring, the circuit is somehow wrong. And the question is why that is. And with the transistor circuit, then you connect the motor to the emitter and to the plus, but here it is different. And why would a motor that dissipates power, because without power it doesn't run, give power? That simply does not make sense. So, connecting the motor again. This should make it run. If I put a resistor in between, what will happen? First this wire, which is the normal one, then the feedback wire, and then resistor. No guaranteed success. It doesn't run. I press the switch, and again it doesn't do anything. I release the switch and I put this wire into the plus. Again, this is not the way it should work. Not at all. So what is the best thing to do? Let's take a look at the lower terminal again. If I connect it to the... This wire is a bit stubborn. If I connect it to the plus, this motor needs stabilization. If I connect it to the plus, then wait a little bit. What happens to the GPIO7 in the lower terminal? Let's wait a little bit. It stays 0. That's remarkable. I expected it to get to become 1, just like it did, but now with the resistor in place, apparently it doesn't do so. I press 1. So what happens to 7? It stays 0. So the resistor makes a difference. But that's not what the intention is. Oops. Let's find out, or try to. So far, the motor runs, but not controlled by the robot operating system. What's more, it turns out that the LED is not controlled by the robot operating system, but by the motor, somehow. So what I'm going to do, again, is take the motor out of the equation. And what does that mean? That means that I want to control the LED by ROS. And that should be actually done in the same way. So I press the switch and the LED should start to burn, which is not happening. So if I take out this resistor and I take these wires out and put them, let's say, back in place, what happens then? Well, unfortunately, the LED is not doing anything, and neither does the GPIO7, as you can see in the lower window. So it can be done, but the problem is that it should be done with the GPIO11 or 12 in this. 7 is out and 12 is the control or the check for the signal. And the fact that GPIO7 is off, well, it should clearly be on. So let's take another look at the publisher and the subscriber. Publisher, upper window. The data is inserted in a single value matrix, array, table, whatever, and then in the subscriber there's a number, and that number says, okay, I get 1 from the database or from the array, and that means that output 7 is true, becomes true. So the status is read back right from here. It's the same lane physically, so then GPIO would be true, which is not happening. And let me press it again. Upper window here says yes, it is 1, but here GPIO7 says 0. Not okay. Then I can also take a look here, because this is 2, this is 6, which also means that this is 7, this is 8, 10, 12. So that is alright. Everything about that is completely accurate. So what is the problem then? I have seen that it can be 1 using the motor. Should it be would it be necessary to put in a transistor once again? I can try that. It should be possible. So let's just go for that solution. Put this one in, and this is the check, and this is the output. But then I need to have another LED for the output of the transistor. So let's find another LED with known working, and then I need another jump wire to put it in. So I take 2 very small jump wires. One goes here. I have to connect it to the ground, and this is a very large one. And another large one. So let's do that, see what happens. So one jump wire goes in here, but it is wiser to first connect one here. So first take this LED out again. Then put the jump wire in place somewhere around here. that is not good. Should be a rather easy fix. In here and in here is better. Then the LED. And another jump wire. To the ground. So, and then will this work? And yes, I have now two LEDs next to each other, but will something work? Well, not really. I'm not really convinced. So let's put a complete old configuration back with a resistor in between. And now I have to keep in mind that lanes are interconnected, or these gates are all holes are all interconnected except for this one. So now the wires have to go. This is the feedback, and this is the output. What happens? Does anything happen at all? Nope, nothing is happening. Does it make contact at all? Very good question. It's quite bent, but it does make contact. And the question is this LED correct? Take a look at the LED again. Yep, mine is correct. So this should be connected just like this. So why doesn't it work? The only thing I can do right now is taking a multimeter and have a look at it voltage wise. So let's just do that. Motor out of the equation. So then this is minus, and here we have a plus, here we have a plus. 0.22 volts. Ooh, that is not enough for an LED to burn. By far not enough. Then on this side of the resistor, nothing. Yeah, which is logical because the output of the GPIO is 0. So that is the first thing to fix. But how? Alright, so when I measure the voltage for the transistor, it doesn't matter if I press the switch or not, the voltage is 0. And also GPIO 7 remains 0. So something is not quite alright there. The question is, what is causing the 0? Because it used to work. And then the obvious thing is it due to the software? Well, the only thing I can test is say, okay, I have no longer a motor in the circuit. I change the sleep to 1. See whatever that helps. So I save it, start again, and I am pressing the switch. And if you look closely, then the timing goes, but the switch doesn't. Well, GPIO 7 doesn't switch to 0 from 0 to 1. And that's really weird. That's very weird. Let me turn the light away. No, the LEDs are off. So this is really remarkable. And now it is 1. Now everything is 1. But the LEDs are still off. I release the switch. How fast does GPIO 7 become 0? That is taking a long time. A very long time. Should I even use a sleep in the subscriber? Because right now, as you can see in the upper window, it's been at least 5 seconds, 6 seconds that I released the switch, and still the GPIO is 1. GPIO 7 is still 1, and I don't even hold the switch anymore. So what is going on here? That's not good. This certainly is a matter of software. And considering the amount of time that I have left in this video, I will bring it to the next one, to the next episode. Why is the GPIO 7 responding so oddly? It used to work, and now it doesn't anymore. So, what did I do this time? Find that the motor, even the XS motor, doesn't run properly. That may be due by lack of pulse width modulation. But in another project you can watch that pulse width modulation is still a problem on the Raspberry Pi. So watch that series of videos if you want to follow the pulse width modulation experiments. For now, for this experiment I've taken the motor out of the equation, put LEDs back, put the transistor back, and now I'm back to code. and it has taken a long time since I released the switch, and GPIO 7 is still 1. Makes no sense. If you like my video and haven't subscribed yet, please do so. If you don't want that, you can also subscribe, follow me on Twitter. You can follow me on Instagram. And you can also visit my website for more information, also to make a small donation if you like to do so and want to support my blog and videos. And this is going to be continued for sure. So, bye bye.